Welcome to the Deep Dive, where we sift through the sources to bring you the most compelling insights. Today, we're taking a deep dive into the surprisingly rich history of an unsung hero of industry, the forklift truck. You see them everywhere, right?
hmm
Navigating warehouses, deftly lifting pallets, just a constant presence in the backbone of global logistics. But if you ever really stop to think about the journey this crucial machine has taken, our main source for this is a really comprehensive history from Angus lift trucks. It lays out the whole evolution. So our mission today is to pull back the curtain on this industrial workhorse. We'll trace its transformation from pretty basic tools to the high-tech automated marvels we're starting to see now. And we're going to uncover some genuinely eye-opening facts along the way, things you might not expect.
It's pretty remarkable, isn't it, how something so fundamental to modern commerce and industry, often just operating behind the scenes, has such a continuous and complex story of innovation. I think by the end of this, you'll probably have a newfound appreciation, maybe a few aha moments about a machine that's, well, far more complex than it first looks.
Absolutely. And to really get why the forklift was invented, you have to picture what came before. Think about the sheer physical challenge. The pre-mechanized era, docks, railway yards, factories, all relying on people lifting incredibly heavy loads. We're talking grueling, just back-breaking work, moving goods purely by human strength.
Yeah.
The very earliest precursors were these simple two-wheeled hand carts, often called sack trucks. They gave a little bit of help, letting workers pivot heavy sacks or crates, especially on railroads and docks. But even these really basic tools saw an early spark of innovation. Some were fitted with manual hand cranks. This meant a user could lift a load, maybe a few feet off the ground. Modest, yes, but a big step away from pure muscle power.
Yeah, and that small innovation, the hand crank lift, it's actually a really critical piece of the puzzle here. If we step back and look at the bigger picture, it represented the very first conceptual leap away from only using human power for heavy lifting. It wasn't just about moving things side to side, it was about lifting with mechanical assistance. This seemingly minor thing subtly laid the groundwork for the huge industrial mechanization that came later. It sort of set a precedent, that machinery could help out or even replace human brawn.
That makes total sense. A small step, but a crucial one. Now, as the 19th century was ending, we started seeing things that look a bit more like a direct ancestor. There was this crude fork truck developed. It had a loading platform that could lift, well, just a few inches. Not really tough enough for heavy industry, but it showed the concept had legs. Then, in 1909, an improved steel version actually hit the commercial market. What kind of impact did that have?
Well, that 1909 steel version, that was a pivotal moment, really. Unlike the earlier ones, which were often, one-offs or just for internal use, this was something you could actually buy. It was a clear signal that there was a growing market for mechanized lifting. Its adoption, even if it was limited at first, started changing how people thought in factories and warehouses. It shifted from wondering if mechanization was possible to thinking about how widely it could be used. It really cemented the commercial viability of these early lifting ideas.
Right, so those early tries were definitely hinting at something bigger. And that brings us to making these lifting mechanisms more formal through patents. In 1867, a man named Van Sickler patented an improved elevator. This device could move and lift materials using a cantilever platform and a hoisting system. Now, that term, cantilever platform, how significant was that specific design? What did it fundamentally change?
That's a really good point to pull out. The cantilever platform was truly transformative. See, unlike a simple lifting table that needs support right underneath it, a cantilever supports the load from just one end, projecting outwards, like a shelf bracket, sort of. This meant way more flexibility in how you could pick up and place things. Imagine being able to reach into spaces or stack items without needing to maneuver the whole machine directly under the load. It was originally designed for stores, apparently, but because it could attach to carts, it could move into more, rugged industrial settings. It provided a basic design principle that, well, it carried right through to the modern forklifts we see today.
Okay, so a crucial conceptual breakthrough there with the cantilever. Then fast forward to 1887, and we see the portable elevator, which built on Van Sickler's idea, but with a more elaborate lifting apparatus. These were incremental steps, sure, but clearly building towards something important.
Precisely. These early designs, from the simple hand-cranked carts right up to that cantilever platform, they collectively built the fundamental conceptual framework. It's a really compelling example of how major breakthroughs often aren't just one big eureka moment. It's more like a series of smaller, iterative ideas, each one building on the last, slowly coming together to create something entirely new.
And what they eventually converged on in the early 20th century was a really pivotal development from the Clark Material Handling Company, the truck tractor.
Hmm.
This machine is often called the first working prototype of a true industrial truck. Can you paint a picture of this thing for us? What was its initial job, and how did it end up changing the whole industry?
Yeah, the truck tractor was essentially a gasoline-powered truck. A real lumbering hulk of metal, you could say. It was designed mainly to move heavy loads inside Clark's own axle manufacturing factories. What's really fascinating about its origin is that Clark didn't initially think of it as a product to sell. It was purely an internal solution to boost efficiency. They just needed to move materials better within their own operations. Simple as that. But then visitors saw this new seated counterbalance truck working, and it apparently sparked huge interest. So much interest, in fact, that Clark quickly realized its potential for a wider market. They stepped up production to corner their market.
Wow, so they sort of stumbled into leading the market.
Kind of, yeah.
Yeah.
It's a classic case of an in-house innovation proving so darn useful that it rapidly transforms an entire industry, even when that wasn't the plan. The sheer utility just spoke for itself.
That immediate demand really shows how effective it was. Okay, so by the 1920s, the push for more power and efficiency in these early trucks really kicks into high gear, doesn't it? What were the key tech advancements that came out during that decade? Well, we saw hydraulic parts being added. That made lifting loads much, much easier, especially for models that had mounted cranes. Electronic controls also made their first appearance, improving how the machines operated and handled in ways never seen before in the history of forklifts. That must have been revolutionary.
Oh, absolutely. A huge leap in control.
And as factories wanted things moved faster, you needed more powerful engines, right? For speed and haulage strength. These improvements weren't just about swapping parts. They actually led to bigger design changes. Things like shorter wheelbases for better turning,
Maneuverability became key.
stronger welded joints for durability, and introducing tilting masts, which helps secure loads better during movement.
What's really interesting here is seeing how different engineering fields came together. You had mechanical engineers working on hydraulics, electrical engineers pioneering those early control systems, and materials science improving the structure. It wasn't just about making one bit better. It was about, synergistically changing this bulky machine into something way more dynamic and capable. Each advance, from raw power to fine control, was directly answering that industrial demand for more throughput, more capacity.
And all those converging advancements led to what many people consider the first actual forklift, like the ones we picture today. This was a 1923 creation by engineers at Yale University. It had a really innovative lifting mechanism using a vertical mast or cantilever, and crucially, it used electrical power to raise the forks and to load up the mast. Sounds like a massive leap forward. But what was its initial Achilles heel? Well, despite being so innovative, it had this major problem. The pallets used for lifting did not always fit the forks well. You can imagine that created a huge bottleneck. It slowed everything down and made it hard for companies to adopt it widely.
Right, a mismatch. Big problem.
Thankfully, this critical issue got sorted out in the 1930s. First, with the introduction of universal pallet sizes, and then shortly after, standardized dimensions for the forklifts themselves were established. So practically speaking, how did the standardization change things on the ground in industry?
Oh, that standardization was an absolute game changer, seriously. Just imagine the chaos before universal sizes. Every warehouse, every factory might have used slightly different pallets. So a forklift from one maker might not work perfectly with another company's pallets, or even pallets from a supplier. It would create massive inefficiencies, wouldn't it? In loading, unloading, storing.
Total nightmare.
Exactly. By standardizing both the pallets and the forklifts, suddenly everything could work together across the whole supply chain, interoperability. It dramatically reduced friction in operations, allowed goods to move seamlessly, and it basically catapulted the forklift from being a specialized tool to an essential universal workhorse. Without that standardization, the widespread use we see today, it just wouldn't have happened. Not like this.
Yeah, the impact of that really can't be overstated. Okay, so if any period truly sped up forklift development, it was the World Wars, right? Cantilever forklifts, especially, gained more popularity during the Second World War. Why were they so vital during wartime? And what wider pressures did the conflicts put on their development? Well, armies used them extensively, loading armaments, supplies. They needed to do it with unprecedented speed and efficiency. The sheer scale of both World War I and World War II created this urgent, almost existential need for efficient transportation of people and materials.
Absolutely critical for logistics.
And there was another huge factor,
Yeah.
a severe shortage of labor. Mass army recruitment, tragically high numbers of deaths on battlefields. In those really dire situations, mechanizations, including forklifts, basically acted as desperately needed extra pairs of hands. They kept the supply lines moving when human workers were scarce.
Yeah, the intense pressures of wartime often act as powerful accelerators for technology. Things get developed and adopted much faster. Innovations that might have taken decades to mature in peacetime get proven really quickly under the necessity of conflict. The forklift's value in those critical moments was just undeniable. It went from being a novel industrial tool to an essential piece of military logistics. It proved its capability under extreme conditions, and that really solidified its future role back in industry after the wars. It's a pattern we see again and again in tech history.
Makes sense. So, post-war, as the economy started booming again, that wartime testing ground led to an industrial boom and a massive uptake of forklifts. They quickly became a common feature in industries and warehouses as production soared worldwide. But as they became so common, a new challenge popped up. They're often large size. They can be a bit clumsy in increasingly packed warehouses. How did engineers tackle that? What lasting effect did it have on warehouse design itself?
Right, size became an issue. So engineers worked tirelessly to scale down its size to easily maneuver warehouse corridors. And this push for smaller, nimbler machines wasn't just random. It lined up perfectly with a key post-war strategy, the vertical expansion of warehouses.
Building upwards.
Exactly. Land was getting more expensive, especially in prime locations, so going up was the logical way to increase storage capacity. Slimmer, more agile forklifts were absolutely crucial for this. They enabled navigating those narrow spaces, and critically, they allowed stacking cargo much higher. This led directly to the development and enduring popularity of the narrow aisle forklift model, which is still fundamental to optimizing storage density today.
So the forklift didn't just adapt to the warehouse, it actually helped shape modern warehouse design.
Precisely. That shift from wide aisles and low stacks to narrow aisles and vertical storage was a fundamental rethinking of warehouse logistics, and the forklift was right at the heart of it. It perfectly shows how machine design and operational strategy are totally intertwined. The smaller forklift didn't just fit into narrower aisles. It enabled the whole narrow aisle concept, maximizing cubic capacity and changing the economics of storage and distribution.
That's fascinating. Okay, so as forklifts became indispensable, focus naturally shifted towards the people operating them.
Sure.
Safety and welfare became much more important. We saw oversight bodies forming, like the U.S. Forklift Association, USFA, starting over 6 decades ago, and the UK's Forklift Truck Association, FLTA, founded in 1972. What role do these organizations play? It's more than just the machines, right?
Oh, absolutely crucial. These regulatory and advocacy bodies are vital. They ensure that the constant push for technological progress doesn't forget the human element. They focus on balancing innovation with the paramount concerns of operator safety and ergonomic well-being, especially in demanding industrial settings. They push for industry standards, best practices, operator training, basically transforming what could be a dangerous tool into a much safer and more efficient one when used correctly. It's all about designing with the human operator in mind, making sure that as the machines get more advanced, the conditions for the people using them improve too. It's a continuous, collaborative effort.
And we've certainly seen significant improvements in user safety because of that. Mid-20th century brought key things like load backrests and overhead guards. Basic, but vital. Then in the 1980s, ergonomic design really became standard. Things like a protective shield for operators, a rear support beam for added safety to stop loads potentially tipping backward. But safety wasn't the only area evolving rapidly. How have the power sources changed over time? And what sort of tech on board are we seeing now?
The power sources have definitely evolved. From those early gasoline and diesel engines, we now have highly sophisticated battery-powered versions. These can run for hours, produce less harmful emissions, which is obviously great for indoor use.
Right. Cleaner air in warehouses.
Exactly. And there are also models running on liquid petroleum gas, LPG, or compressed natural gas, CNG, offering different balances of power, cost, and emissions.
And the tech side.
Oh, the tech on board now is incredible. Modern forklifts integrate computer systems. These allow operators to do tasks like barcode scanning and reading RFID chips right there from the driver's seat. It makes inventory management and tracking items so much faster, so much more accurate and efficient.
So it's almost a mobile data terminal, too.
Pretty much. Add to that the extra comfort from better ergonomic designs for people working long shifts and the continuing influence of those smaller bodies.
Like that 1954 Lansing Bagnall narrow aisle forklift model.
Yeah, that one was hugely influential. It continues to inspire the compact, modern designs that are essential for working in tight, restricted spaces. It's all come together.
It really is a holistic evolution, isn't it? Every aspect, power, safety, digital smarts, comfort, has been refined. It's turned the forklift into this integrated mobile workstation.
That's a great way to put it. The real-time inventory stuff, for example, it doesn't just move goods anymore. It turns the forklift into a moving data collection point. That fundamentally changes how warehouses track and manage their entire flow of materials. It's really no longer just a lifting device. It's become an intelligent node in a very complex logistical network.
That's a powerful shift. Okay, so looking ahead now, what's on the horizon? What's the road ahead for these machines that just keep evolving?
Well, one of the biggest shifts, no surprise really, is automation. The future definitely includes computerized guidance systems operating forklifts without direct human assistance. They'll use things like sensors and laser guidance to autonomously pick, deliver, and even track loads. Imagine whole warehouses where these things just, well, run themselves.
It's coming faster than people might think.
And power-wise, electric-powered forklifts are really set to dominate even more. The general expectation is they will take over as gasoline, LPG, and CNG-powered vehicles are slowly phased out, especially with environmental pressures.
Makes sense.
And there's a rapidly growing segment, hydrogen-powered fuel cell forklifts. These are getting a lot of attention because they're eco-friendly, offering that environmental advantage. Quick refueling, zero emissions at the point of use. What's really compelling here is this clear, accelerating trend. It's not just about being more efficient anymore, it's towards sustainability and full autonomy. These advancements aren't just small tweaks. They reflect and respond to these huge global shifts in technology, environmental awareness, and even labor dynamics. This isn't just, a new model year for forklifts. It feels like an exciting new chapter for industrial logistics itself. It's fundamentally reshaping how we're going to move and manage goods globally.
And the market figures certainly back that up. The projected growth numbers are pretty staggering. In 2021, the global forklift market was about $56 billion, but it's expected to reach $91 billion by 2030.
Yeah, that's almost doubling the market in just under a decade. The demand is definitely there, and the innovation is absolutely keeping pace. So from those really basic hand-cranked carts and the first truck tractor to today's digitally connected, increasingly autonomous machines, the journey of the forklift is just an incredible story of human ingenuity. It remains this absolutely critical, indispensable tool, constantly adapting, constantly pioneering new tech in so many industries around the world.
Indeed. It's such a dynamic story of persistent engineering, always driven by what's technologically possible, but also by that fundamental, unchanging human need to handle materials efficiently. The story of the forklift isn't really just history, it's an ongoing evolution, and it's deeply tied into the future of global commerce and manufacturing. Which leads to a really interesting thought, doesn't it? As these machines become more and more automated, more intelligent, what new skills will human operators need? How will their roles change? Maybe from actually driving the machine to supervising fleets of them, or collaborating with these advanced robotic systems. What does this all mean for the future of how humans and machines interact in our warehouses and factories?
Like a great question to leave our listeners with. Thank you for joining us on this deep dive into the fascinating history and future of the forklift. We invite you to ponder those questions as we sign off, and we'll see you next time on The Deep Dive.